enterprise IT landscape. But I have to say, if Career Week rolls around and you're working on Spot was probably the coolest thing you could possibly bring to your kid's school. So puts everything else to shame that you could possibly do during Career Week with your kids. So make sure you stay tuned for that. So my name is Jason Corey. I lead our North America technical sales and go-to-market org. What that means in plain English is a lot of the solution architects and the technical sales reps across the country that you work with on a day-to-day basis are part of our organization. The thing I love most about my job is I get to talk to customers from a lot of different regions, a lot of different verticals, and even different sectors, right? Public sector and private sector. The common thread across all those conversations is a lot of them want to talk about innovation, but they also want to talk about innovation in the enterprise. Because a lot of times that's very different, right? Part of what all of us are trying to do within enterprise IT is figure out of all the different emerging possibilities, what are some of those things that really are the signal between the noise. And as Chris, our first speaker, will talk about, today's experiment is tomorrow's biggest enterprise disruption. So really what today is about is really talking about things that can take shape in the enterprise and shape the future of all of our businesses, our missions. Really excited to share that. So to get into that, I want to do a quick introduction of our. So 17 years ago, our current CTO met this really sharp engineer who was working in the telco space on the Zen project. That person was Chris Wright. And the CTO tried very hard to get Chris to come over and work with us at Red Hat. Chris said at the time, hey, love Red Hat, love the technology, but I'm at this point in my life, I'm about to have my first child, right? He's expecting his daughter right around the same time. And he said, not really ready for two big life changes at that time, career change and, becoming a dad. So within the first few weeks, this is a quote from him that I read. Within the first 2 or 3 weeks, he realized that this parenting thing wasn't actually as hard as he thought it was. So he decided he would be okay with a career change. And 17 years ago, all of us at Red Hat are super happy we did, because he's made tremendous contributions to Red Hat, tremendous contributions, a lot of these open source communities we'll talk about today. And just to give you some kind of formality, I had to write this down because his org has grown pretty significantly over that 17 years. Chris is our Chief Technology Officer for Red Hat, Senior Vice President of our Global Engineering Group. Now within that, he leads our Office of Technology, who you'll see a lot of the representatives from that throughout the course of the day, but also our product security teams, our product experience teams, all of our engineering teams, our technical strategy teams, and most importantly, our customer experience and engagement. I think when you think about Red Hat, putting those types of organizations under one leader, it says a lot about what we want the experience for all of you, our customers and our partners to have. And I'm really excited today to welcome Chris up to the stage to kick us off with his keynote.
Thank you. Tell that I'm not the best at things. That's a true statement. My understanding of parenting, boy, was I wrong. Easy to remember my work anniversary because it's tightly correlated with my daughter's birthday. I do have a burgeoning 17-year-old at home, which is a different adventure. Anyway, thank you. Good morning. Welcome. I just wanted to, first of all, appreciate all of you spending your time with us. I know your time is valuable, and we can sort of help you stretch your thoughts and think about what's happening in open source and maybe how that could impact your businesses. And so I think we got a slide issue, but I'll just say early days for me, same thing. Early days for me, my interest was partially in tormenting my younger brother and partially in space. And so I was sort of amazed by constellations. I really enjoyed locating specific constellations. I like just watching these across the sky. Now, it turns out those weren't actually stars, they were satellites, and this was kind of a world-changing realization for me, where I realized that there's these computers with precision through the sky looking back down at me. Now, today, we don't have to wait till the sky darkens. The velocity of technology and the change that's there we go. So if you think about what's happening today, during the day and at night, we have things like intelligent drones that are buzzing around cities, monitoring traffic, creating synchronized art shows in the skies, which we did this summer in Austin, helping first responders detect threats like fires, floods, and now, I understand it, in Dallas, get ice cream delivered to you by a drone that they guarantee will still be frozen. Now, and I don't know later, but we should. The speed and velocity of technology. We go next. Kind of the premise of this conference. This together to talk about technology trends, emerging technology, we see things going. And I'm really happy that you're here with us and the Office of the CEO. So you're going to hear about a lot of cool things. I'll touch on a few of them, but you'll hear a lot more today. Cool things that we're doing in emerging technologies with open source software. These are things like developing pipelines for AI applications, creating an end-to-end software supply chain security, extending the Red Hat hybrid cloud, which we've been talking about for years, all the way to the edge, which includes satellites, space stations, drifting among the stars. Awfully cool. So, back down here on Earth, we believe that open source is the innovation engine of the industry. I mean, all of the industry. Everything that we do at Red Hat starts upstream community and open source projects. And our approach is pretty unique in the software industry. We play in both of these worlds, this open source world, kind of the wild west of technology, and the enterprise world. How can you harness that innovation and bring it to bear in business? And that is the innovation model that guides and inspires our emerging technology work. So our emerging technologies goal is to identify upcoming challenges and develop open source solutions. And we participate in projects, we evaluate new opportunities in open source communities, and we create products and services for Red Hat. Now, I'll add that when it comes to that gating part, our create technology. That's with customers, partners. Our emerging technologies teams can really explore cutting-edge technologies that can be integrated in business within, say, prototyping on innovation-focused projects dependent from the product teams and our current roadmaps. It's all this exciting work allows us to sort of drive forward efforts to bridge that wild west of open source. Because as you heard from Jason, the way I like to think of it, today's experiment in open major changes in the big part of what we're doing today, and it's what we're going to talk about. So let's look at our emerging technologies focus areas. I'll just run through the list. You see cloud security, applicational infrastructure, edge computing, open services, multi-cloud networking, sustainability, application platforms, AI. Call your attention to a couple of these. And security today are board level conversations. Really important topics. Some more emergent than others, but really interesting areas of technology exploration. Area that I like to highlight is educational infrastructure, which as an operating system geek, it thrills me that hardware is interesting and evolving and changing, and it's a big part of what fuels opportunities on the edge. How you compose new systems out of accelerators and new hardware, we need to make sure that we're evolving not just the OS, but the entire application stack above that. An interesting area called open services is take the open source development model and apply it to the creation services, cloud services that we deliver. What does the community look like in that context? Tools can we develop together? How can we even operate things together? So a bunch of other technology areas, but it's a lot of interesting and exciting things, and we'll touch on some of those throughout the rest of the day. So one area that we're especially active in is infrastructure to support AI, ML software development, edge computing, ensuring at every step of the way. I know you've heard it all before. Edge is the future, but the numbers don't lie. We're on track to collectively generate petabytes of data, kind of hard. But it's huge. And this, in conjunction, high performance, low powered, low cost edge computers, presenting this unique solution. The computation business logic is moved where the data is being produced right at the edge. What a cool new experience that we're having. All right, so for example, let's take that drone that's flying out there delivering ice cream in Dallas, and I have to admit, last night with one of the companies that's responsible for this, my understanding is they've can't actually get ice cream right now. But under the hood is this advanced AI ML inference engine deployed on top of a powerful GPU running on an edge device. Software is gathering inputs from cameras and gauging altitude and using GPS and monitoring temperature, making real-time decisions. All the while reporting status back to a centralized control plane in the cloud. And take a look at that scenario. It presents a number of challenges. First would be development. Data scientists who build AI and ML models need an easy way to push model updates to various edge devices in deployment. Next would be supply chain, 650% year-over-year increase in open source supply chain attacks. And business logic is especially vulnerable on an edge device rather than in the four walls of the secure data center. And then third, let's look at operations. Designers need a way to orchestrate the large distributed applications, which consists of components and on edge devices. So let's dig a little deeper and demonstrate how we're kind of mitigating the risks, making this opportunity real for our customers. First, we'll look at cloud-native AI ML development. Data scientists and machine learning engineers are ranked the most in-demand fields in technology. Really hard talent to get a hold of. These roles focus on the creation of trained AI ML, typically in an interactive notebook like Jupyter Hub, support for languages like Julia, Python, R. And through managed cloud services, these notebook environments can be run on the cloud and accessed through browsers. And this itself can drastically speed up by the overhead for development. Project Meteor, which is from Red Hat Emerging Technology, provides you a bring your own notebook kind of environment service in the Red Hat hybrid cloud. So now with the click of a button, you can spin up entire Jupyter Notebook fully configured with the AI ML application environment. And then through the web browser, you can train models, you can tweak parameters and run experiments, you can graph the results, and then you can publish those results. Okay, so how do you take that model and deploy it safely to an edge device? Cloud can kind of cater to the specialized role of the data scientist by offloading software build and deployment processes into an automated CI/CD. And these are automatically triggered via GitHub webhooks or something like that when the data scientist pushes their model. And through the use of Tecton pipelines, end-to-end security measures are integrated across the software's development and deployment. So within the build pipeline, cosign, which is a part of the SigStore project, is used to capture graphic signature of a container image as it's created. The image and signature are then pushed together into a Quay repository, and then that signature will be pulled to the device along with the container image so that the image can be validated by a Kubernetes admission controller before it's deployed, building some integrity around the system. Now, to trust verification of the container images, we first have to trust the verifier, which in turn means we have to trust the entire software stack running on the edge device. So for this, we can use Keylime, originates with Red Hat Emerging Technology teams, provide boot time attestation and runtime integrity of our device. Use a TPM, trust, Keylime monitors the integrity of the system during the runtime, and then we can check for discrepancies such as file modifications, installed packages using Linux integrity measurement architectures. Full comprehensive system to manage the security of what we're deploying out on an edge device. So how does this come together for an edge deployment? Another interesting advancement is on the operational side with Microshift. Microshift is experimental single node OpenShift that's engineered for embedded deployments with low powered CPUs and a small number of gigabytes of RAM. So by connecting our edge device to something like a Red Hat Advanced Cluster Management instance, Microshift provides this seamless integration of the edge devices with the hybrid cloud infrastructure we've been building for years. So now our applications be deployed directly to the edge and managed using the standard kind of OpenShift tooling and services. So I will ask you, did you know we put an instance of Microshift aboard the International Space Station? Okay, some of you did. Yes, we did. Yes, that's cool. Yes, we put Kubernetes in space. And you can just guess, my inner 8-year-old is, this accomplishment. So let me sort of summarize what I've talked about so far. I've shown sort of the technologies involved needed to deploy an AI ML model and software stack on a modern edge device. We've enabled data scientists to use familiar tools like Jupyter to interact with their AI ML environment, and then using GitHub Actions and Tecton pipelines, build and deployment processes of their applications, models are fully automated. Finally, we've shown how the container signatures are verified at the time of deployment to ensure the integrity of the application. Runtime integrity of the device itself is provided through Keylime and other services. Earlier this year, our emerging technologies engineers built an end-to-end MVP of a secure AI edge application. For the MVP, they used an autonomous toy driving car called a donkey car that was running basically a Raspberry Pi and Fedora. And our MVP integrated all of the technologies that I just spoke about. Meteor to train the application model, Tecton to build the containers, Big Store Cosign to sign them, Microshift and Keylime on the operational side, deployed to the device, provide that secure environment where the car application and model can be deployed. And beyond just being fun, our engineers to play with, we see this toy car MVP as a blueprint, a template, a model, a whole set of edge application use cases. I'll give you a few examples here. We have the drones that we've been talking about, building, delivering capabilities in cities. We talk about businesses, so it's not just smart cities, it's homes. The applications here are endless. So we talk a lot about industrial automation, sensors and sensor-produced data, devices. You'll see Spot later today, which can think of Spot as an edge device, AI model, do interesting work in a hazardous environment that humans might not want to be a part of. So it's a really awesome set of opportunities that we're demonstrating with the donkey car. Like I mentioned earlier, delivery drones are popping up across major cities, so it's not just in Dallas. Still early days and experimental. I know recently also here example of autonomous trucks with JB Hunt showing the future of delivery and looking at how you can reduce the carbon footprint of delivering goods across the country. So I mentioned that notion of smart factories. And if you think about the vehicle, I would call it a data center on wheels. The vehicle is more computer than car these days. And at Red Hat Summit back in May, we announced Red Hat and General Motors a partnership to build an in-vehicle operating system. So another type of edge device where in the future our cars will be more connected, autonomous, and you can do that safe delivery of software updates right to the car parked in your car. So I hope that kind of gives you just a glimpse of what we're working on right now. And I know we've got a lot more to share with you. You'll hear from on the details. This is the results of collaboration that we do with open source communities, customers, partners, and me looking up at those stars many years ago. I hope it opens your eyes to some opportunities, some cool ways that you could solve challenges within your businesses, building from the technology that we're creating today into the future. So I want to say thank you, and I will turn it over to John, who has exciting news. Thank you.
All right. I'm properly blinded by the lights. Okay, so hello, everyone. My name is John Archer. I'm been with Red Hat since about 2015 and worked a lot with energy customers since I joined here, but now I'm helping customers and partners specifically run on our infrastructure. So identifying computer vision stuff and doing AI at the edge is something we've been doing with some energy customers for a few years now. But today we're here to talk about, while we get the slides up here, we're going to talk about, what Chris just talked about, smart factories. We're going to go kind of next level of detail on what is a smart factory and how Red Hat and Intel together are trying to make that happen. So.
Maybe just a quick way of introduction. Raghumoorthy, part of Intel, manage the Red Hat relationship, also the CTO for the account as well. We kind of focus on all aspects of relationship with Red Hat, right? From kind of doing the engineering work for our early silicon, right? We work years in advance getting that enabled, building solutions, and then scaling with our partners. So we kind of span the entire spectrum of the life cycle of silicon with the software with Red Hat.
So real quick, let's just I think everyone may have recognized what this is here, but I don't know if everyone remembers the manufacturing delays, right? Some of the challenges. My sister-in-law was a COVID nurse, and she used to keep a mask in a Tupperware box because of the lack of access to masks, right? So I think for a time there when COVID first started, we had a manufacturing challenge. And part of the things that we'll talk about today is about how organizations can start managing, we use this term Industry 4.0, and some folks are saying Industry 5.0 now. But really, at the end of the day, most organizations are barely what we'd call Industry 2.0, right? And some of this is, raw materials. So this is, part of the contention in improving and modernizing manufacturing is the OT side of things is usually very manual. There's a lot of USB guys, guys with USB stick running around updating PLCs or DCS systems. But one of the real challenges is that there's the manufacturing agility is really what, when we talk about digital transformation in manufacturing, it usually has to do with, the OT assets. So, starting to manage the OT assets like IT assets is what a lot of our customers are asking for. So we'll talk a little bit about how we can start doing that here today. If you look at that previous thing where you saw the mask being manufactured, there's PLCs that run an actuator that creates the folds, that does the sewing, that cuts the fabric, right? That's all automated. So that's a couple pieces. But imagine the amount of PLCs and DCS systems, photo lights, conveyor belts involved with these industries. If you want to build a new battery manufacturing plant or a new auto manufacturing plant or modernize the current processes, it is very slow to make changes. These processes are very brittle. They're not well understood, right? We go back to the old Ford automation and, how we used to build a Model T, right? It's changed a little bit since then. We've gone to more robotics, obviously, in a lot of these use cases, but it isn't fully automated, right? But it's the systems that run that automation is still very manual today. And this is across many industries. So what we've been seeing, and I've been working with ExxonMobil. I live 10 minutes from the ExxonMobil campus. They've actually been telling their vendors, we want open interoperable mechanisms. We want to do best of breed with the OT systems. And so what we're trying to do here together is make sure that things that needed real-time operating systems, we can address those needs. There's some gaps today, like from newer technologies like time-sensitive networking and TCC type things to help ensure that the robot doesn't hit someone in the head. Those safety issues are critical too. But really what we're trying to do is get to allow, most of these OT vendors are closed proprietary lock-in style delivery today. And the customer is going to make it a check mark eventually. You need to be open, right? And so Red Hat and Intel together are working on projects that we'll describe here that are the foundation for how we start doing that. So I mentioned a few different industries we've been working in. I've circled the ones where we've got evidence that these guys are really wanting this openness and interoperability now, right? They've created a consortia groups to try and get the vendors to work in this new open way. And the OT vendors, for some of them are like, yes, let's go. We understand the need to do best of breed and to start leveraging these new innovations around computer vision. So like in an auto factory, there's auto welding inspections that need to be done that a robot does, right? Or how well the paint job was done, or how tight the nut was screwed down, right? Things like that can be automated. But really what they do is they sell a turnkey solution that ties only to their SCADA or to their DCS device. So what we're trying to do is build a kind of this mechanism to allow the customer to innovate and bring their own custom innovations to it, and then pick the best version of a MES package, for example. So those are the areas where we're focused, and these industries circled here are kind of leading the charge in helping with these consortia areas. So, Raghu, you want to talk a little bit about the pain that some of these guys have?
Yeah.
I'll give you this here real quick.
So I think John summarized it well, right? Lots of pain points in the current systems. obviously the primary driving factor here is to get that flexibility, and obviously get the cost benefits of moving to the new systems, right? So it's a quick kind of list of key challenges that you see, right? The lack of interoperability, right? You have so many different vendors that are plugged into in any given factory automation scenario. It's really, not at all interoperable. How do, if something breaks, how do you go fix it? And obviously the cost of breakage is extremely high, right? Probably even an hour of breaking in a production line is going to have a multi-million-dollar kind of an impact, right? So that not having that interoperable system where you can kind of move like one, PLC controller to another one is not easy because they're all proprietary, hooked up in very proprietary ways, in kind of very brittle ways, right? So these are the challenges that we have to address as we move forward into the kind of the next generation. So if you look at this on the chart here, right, what you see here is this is kind of our legacy system, right? You have proprietary kind of workloads, which are very, the workloads tied to that specific hardware that's custom built. And increasingly it's harder to get these engineers who can even fix this or upgrade it or do anything with it, right? That's the challenge we have right now, and it becomes more and more expensive as we move forward. Now, what we really want to get to is this kind of this state, where it's software defined, and it is the entire application, from the endpoint that it then connects to essentially general purpose compute, that then can be deployed at scale and managed at scale. It's flexible. So that's really the end state we want to get to. Okay. How do you make this happen? Right. So from an Intel's perspective, we've kind of have a strategy around our industrial edge, right? How do you get from this current state to our future state? So as being Intel, you would expect that we would have the hardware for it, right? Which is absolutely true. But with that hardware, it's not just any hardware. There's a lot of pieces that go into the hardware to make that usable in the context of an industrial edge, right? It's got to have the time critical, components to it. So you have to be sure that when you have a piece of hardware, it is, and you have different workloads with different requirements. There's some real-time requirements, there's some, time critical elements within the, that's a key part of that. I think Chris alluded to making sure that it also has to be secure. So we need to have a layer of security from hardware on up, right? Everything starts with the hardware, right? And from a security perspective, how do you enforce that whole security layer, from hardware on up? That's a key part. Then when you have systems that have to be interoperable, right? So when you have, that are connected, through Ethernet, how do you make sure that there's a time, synchronization that happens between these devices so that a workload that requires, ultra high, reliability is prioritized over a different workload that is not. So all of those pieces from a hardware perspective have to come into place. And that's really what we focus on from a hardware perspective. And it's not just the hardware, it's the kind of the layer of software that you need along with it, right? And then that's kind of part one. Part two of this then is how do we put all of these together and really make, right, at the end of the day, when you make the software defined, you have multiple workloads running at that endpoint. How do you then make sure that these workloads can be consolidated and still have those traits? Because you'll have in a given endpoint, you may have a workload that requires a very time critical kind of element, right? Something goes off, something needs to be turned, has to be shut down immediately, right? There's a time critical element to it, right? So kind of putting all of that together is the kind of the software layer we need. And then beyond that, we need to orchestrate that, right? It's not just one point, right? It's the whole ecosystem of how everything has to be orchestrated across, the entire production line or across the entire factory, right? So that entire piece also has to be there. So these are the kind of the key elements of what is really required for us to make this possible. right? And that's really from an Intel perspective, that's our key strategy. And the way we do that is, and then it's not just going and, building the two companies together, right? We have to have an ecosystem of, industry standards that we have to comply with. And so we need to make sure that all those work that we do, both at the silicon level and at the software level, is upstream, so that partners like Red Hat can then take it and actually build applications and full solutions that are actually deployable at scale, right? And then, so really from an Intel perspective, there's two pieces of, software that it's actually more of an SDK. It's called Edge Industrial ECI. It's control for industrial, and then Edge Insights for industrial. These are essentially, think of this as the real-time element and the kind of the AI or analytics piece of this, right? Both of that has to come together for this to be viable, right? And so this is kind of a very high-level view of what that looks like, right? So I kind of refer to these two pieces, right? This is the, I'll kind of start with the Edge ECI piece, right? Which essentially, think of these as kind of a few key elements. It's that time-critical element. It's the network, time-sensitive networking element. The functional pieces, right? You have to make sure that the hardware is functionally safe, right? Especially when you have an autonomous car or a drone, it's got to be safe. So that whole safety layer of making sure that there's redundancy available at the silicon level and at the kind of the software and the firmware level is one of the key pieces, right? And then lastly, the security, right? It has to be all secure end-to-end so that you can actually build an end-to-end pipeline that is completely secure and deployable in a secure fashion. So those are the key pieces that go into our kind of that ECI piece, right? And then this part two of this is, right, is how do you take and make sense out of it, right? So you have an entire end-to-end pipeline of something that's coming in, right? Some data flowing in, whether it's video data or time-critical, time series data. How do you take that data, make sure that it's ingested at scale, right? In real time, right? Inline type of ingesting. Make sure that you can process it, you can store it, and you can make sense out of it, right? That whole pipeline is extremely important for you to act and do something, right? Because once you send something, you have to go plan to do something, and then you actually have to act on it, right? That whole piece of, pipeline is what goes into our Edge Insights, piece of software. So these two combined essentially gives the framework that, Red Hat and Intel partner with, and then integrate that into our product, okay? So with that.
Yep, okay, thank you. So what we're doing together is, building out these reference architectures together. So we've built a lab that we'll talk about here in a second. But what we're trying to do is solve these things listed here, how to do inferencing edge in a manufacturing site and meet all the security needs. So things like colonial pipeline don't occur again, right? So securing these assets, doing the security in depth, kind of modernizing the Purdue model where customers are ready to do that. Those are types of things that we're working towards. We have a reference architecture out there for this manufacturing concept where the large package software would need orchestration, and then we'd have Ansible management and real-time used in some of the other things where we're working towards new networking capabilities, but also trying to also advance the compute from a low power from a power consumption standpoint, as well as just how to keep that model healthy, even though it's in a disconnected network. So one other thing that we're coordinating this through some industry consortia here. So specifically, we're working within the Open Group on the OPAF and OSDU standards. So ECI is definitely tied to the OPAF consortia, started by ExxonMobil, who's trying to get these OT guys to play ball, I guess we'll say. And then OSDU is more focused on oil and gas. Like we're doing a well pad controller application as one of our MVPs. So you won't have to drive to, the windshield time, these oil and gas guys call it, can be reduced, which can lead upwards to $5 a barrel savings if we can get that right. So what we've done is launched in a co-working space on the west side of Houston, the Energy Corridor, at a place called the Cannon, is now this joint lab. And so we have ability to bring customers in, partners, SIs, ISVs, and work on, if we have engineering gaps, work on it there and test it. We have all these test systems. Everyone here might be familiar with RHPDS, but you can't touch an HMI screen at RHPDS, right? You can't ensure that the interactions that a customer wants to have on how they do their touch panels with SCADA, we need the ability to go touch things. And we also need to expand our ruggedized networking support. So much of this is, we worry about the workload, but there's a lot of dependencies networking wise that can be Ansible-ized in the space. So we're doing that here as well. So we're opening this up first week in November. It's, if you're interested in coming in and checking it out, get in touch with us. We're going to have, this open concept, so we'll sign up. We're working with some energy customers initially, so we already have Chevron and Exxon in the space. We're actually conjoined with the Chevron space where we have access to a lot of sensors, 5G towers, solar-based power systems to do that lower power testing. So a lot of these these edge devices have our power rating, but it's the power under usage that we need to measure so that we don't think it's going to work, deploy it, and find out we're not going to have, coverage based upon the sun that day in the Permian. So, but we've got a lot of partners in the space. So we got a lot of hardware partners have come in and brought in, made donations, as well as some other software vendors. So, OPC functionality, Modbus functionality is in the space, in addition to having, SCADA vendors like inductive automation. So we can actually build that, what an OT guy is used to. We're accommodating to that and making sure that all runs safely and securely, and we can automate those deployments at scale. So if I need to go brownfield or greenfield, update my warehouse or my factory, we can do that workload. So we'll be building these things as validated patterns and publishing them out. So thanks for your time, and if you want to talk to us later, we'll be around.
Yep, thank you very much. Really appreciate it.
All right, so great kickoff to the event. We're going to take a 15-minute break and come back at 11:30. The one thing I want to challenge everybody to do, though, I think the last 2.5 years have shown us that it's really a privilege to be able to get together in person. So I think, strike up a conversation with someone new. There's obviously a lot of folks from Red Hat and our partner ecosystem here. You could definitely find Nodin right there. Nodin is rocking his Red Hat Fedora. He's always an easy one to find. But use the lunches, the breaks in the afternoon to get to know somebody new and learn something. So thanks to all our speakers, and we'll see you back here at 11:30. Get things going here. So everybody.